In order to use the second derivative test, first we recognize that the first derivative is equal to 0. That means that we have a critical point when x equals 5. But the second derivative is 2, so that means it's positive. And remember this little picture. If the second derivative is positive, that's the old smiley face, making the function concave up, and that 5 is happening right down here. Therefore, the local minimum is going to occur at 5. For the next one, we have f prime of 7 equals 0. That means that the critical number is 7, and the second derivative is negative. So if the second derivative is negative, that gives us the old frowny face, and with our critical number at the peak of that. So that means that this is going to be a local maximum that happens at 7. When the second derivative is 0, that doesn't tell us much. It tells us that we might have an inflection point, but we got to go back to the first derivative and to really see what's going on. And here, we'll have our critical point at 2, but looking at the sign chart here, f is going to be increasing until we get to 2, and then it'll increase again, right? Making this an inflection point at 2. For problem 4, let's go through all the pieces. First, finding the critical numbers. That means we have to look at the derivative. And the derivative here is 6x squared minus 6x. And to find the critical numbers, we set the derivative equal to 0. So factoring that, we'll have a 6x times x minus 1, which means our two critical numbers are going to be 0 and 1. So we plot them and take a look at the sign chart. So picking something less than 0, anything negative will make this negative, and it'll make this one negative, so overall positive. Going in between, this becomes positive, so the whole thing's negative, and then we pick something positive, everything's positive, and there's our sign chart. In part C, it asks us to find the second derivative. So since the first derivative was 6x squared minus 6x, to find the second derivative, we just take the derivative of that, and we'll get 12x minus 6. Now, we can use this space to help us figure out part D. Where do the local minimums and maximums occur? Well, first of all, we know that we have a critical number at 0. So something's going to happen at 0. And so we check the second derivative at 0. When we plug that in, we'll get negative 6. Since it's negative gives us the frowny face, that means that a local max would have to occur there. And then doing the same thing for our other critical number of 1, we'll look at the second derivative of 1, which when we plug it in, we'll get a positive 6. Remember, positive gives us the happy face. So this is a local minimum that's going to happen at 1.